Hi, this is Cliff Montaigne from the Department of Land Resources and Environmental Sciences at Montana State University. I'd like to share with you ideas about the geologic setting for the Bridger Range and Bridger Canyon, how the bedrock geology and the superficial geologic processes influence the landscape, the ecological processes occurring on the landscape, and the suitability for different kinds of land uses. So the Google Earth image shows the north-south high-standing Bridger Range along the cursor. It also shows that the Bridger Canyon Highway and then Bridger Creek parallel the high-standing Bridger Range until at the lower part they turn to the west and actually cut at right angles through the Bridger Range. If we look at the geologic map and the topography at the same time, we see that north-south trend expressed along the cursor, where the blue formations are essentially the high-standing, most resistant limestones and some sandstones, and the green formations are the younger, less resistant rocks that tend to occupy the bottom of Bridger Canyon, where the terrain is more gentle and where the soils are thicker and more supportive of life. Here the geologic map again shows us the Bridger Canyon Highway going through the meadow country of Lower Bridger Canyon, making that right angle turn and crossing through the steep canyon just above the fish hatchery. And we see again the purple and blue formations that we think of as the core of the Bridger Range, especially the Madison limestone, which rises high along a good deal of the Bridger Ridge. And then as we move to the east, the K stands for Cretaceous geologic age, a time when the sediments formed were mudstones and shales, some sandstones and limestones, the time of dinosaurs. And it goes all the way over towards Jackson Creek with the formations getting younger and younger, with in the far right another formation called the Fort Union Formation, consisting of a layer cake of sandstones. So the terrain map shows the same pattern, and again we see the more gentle open meadowlands of Lower Bridger Canyon forming in the Cretaceous rocks, in great contrast to the high-standing Bridger Ridge represented by the Madison limestone and other resistant rocks. And then on the right, this layer cake of Fort Union Formation, mostly sandstones, very distinctive in pattern. Water flows through all of the Bridger Range and Bridger Canyon. Water quality is affected by the chemistry of the underlying rocks, as well as by the physical condition of the surface. Physical condition of the surface resulting in soil erosion, of course, brings us muddy water. The chemical condition of the groundwater beneath, because of, in the case of eastern Bridger Canyon, salt and sulfur-laden rocks, similar to eastern Montana, gives us the very big difference in water quality between water coming out of the Madison limestone and the sandstones and water coming out of, on the eastern part of the valley, the formations that have more sulfur and salts in them. The resistant rocks are, of course, seen easily at the mouth of Bridger Canyon. We get a sense that these are dipped up at a fairly high angle. Lamar limestone, one of the oldest limestones at the core of the range. Limestones are generally porous and water conducting, so the springs that contribute to the Bridger Canyon Fish Cultural Development Center, where we require a constant temperature, constant flow year-round source of water, these springs provide a basis for establishment of fish hatcheries. At Fairy Lake, we get a better sense of the tilted up, steeply dipping angles of these sedimentary rocks, here mostly limestones and a little bit of red shale. If we climb up to Sacagawea, we can see again that very steep dip. Get a sense that this dip is contributing to the high-standing topography of the Bridger Ridge, in contrast to the very gentle, more gentle Bridger Canyon stretched out in front of us. These limestones are full of fascinating fossils. The fossil assemblages vary from formation to formation. Here we see some crinoid stems and probably some other shell features. This rock shows us some shell features along with crinoid stems. Sacagawea shows us that it isn't all limestone, but here is that red shale again, along with a black shale. And notice that the shales tend to form the swales because they are softer and less resistant to erosion. Again, from the pass above Fairy Lake looking to the north, we see a big difference in vegetation. Trees on coarse-grained rocks to the west, more grass and much less forest on limestones and shales to the east. This is due to a difference in the water-holding ability of the sandy soil on the coarse rocks compared to the more clayey soil on the limestone, but also to a difference in the pH. Limestones tend to have a basic or alkaline pH up around 8.5 that is more effective at supporting grass, whereas these particular coarse-grained rocks tend to be acidic in pH, favoring conifer vegetation. So in that cirque we see the limestone fragments making a typical black, dark-colored soil supporting grassland vegetation. Wonderful displays of lichens on particular limestone rocks and certain sandstones. Down lower by Fairy Lake, outcrop of sandstone showing very sandy soil and the support of coniferous vegetation instead of grassland. Again, up at Bridger Bowl, looking to the east along Upper Bridger Canyon, we get a sense of the more gentle grassy terrain of the softer sediments, and across Bridger Creek, across from the Bracket Creek Junction, we see the layer cake nature of the Livingston Formation here in a little bit of an anticline, which comes and then dips back towards flat. And that is reflected here in this extensive outcrop of the Fort Union Formation, which makes the Bangtail Range. Over towards Bozeman Pass, the younger Cretaceous sediments, rich in clayey materials, some sandy materials. Bentonite is a clay we see in the green color, a clay which holds a lot of water, contributes a lot to soil fertility, but also to slope instability. Jackson Creek, the terrain on those rocks, more gentle. The soils tend to be deeper and darker and more supportive of grassland vegetation than the upland soils on the coarser sandstones here in the Bangtail Range or across the way in the Bridger Range. Nice place for goats to control weeds, again in this grassy terrain with the Livingston Formation with a very distinctive showing of Douglas fir above the grassland. Kelly Canyon exposes another set of Cretaceous rocks called the Livingston Group, full of andesite-influenced sandstone and claystone, more of the silty materials. So again, Kelly Canyon has terrain that tends to be more gentle and more supportive of grassland than the higher elevation limestones and more resistant sandstones of the Bridger Range and the Bangtail Range. So the bedrock is really important, but on top of the bedrock, water, wind, temperature, glaciation, erosion, deposition, those features are working to modify bedrock to make the modern landscape. So here is a steep chute of material that's rolling downhill, sliding downhill by gravity called colluvium. And then we have a more rounded feature here, a glacial moraine. Looking down into that same cirque, we see that rounded glacial moraine, which has a pair on the other side. And in both cases, these glacial moraines are being overwhelmed and covered by modern talus from the steep valley slopes. And then the valley itself is being filled with alluvium coming from mostly springtime solifluction and debris flow activity as the snow melts, the rain falls, and these materials get filled with water and gravity pulls them down slope. So here we're looking at flood levees on both sides of this small stream channel. And we can think of this as a process that is filling up the basin. So looking down in the basin, we see those flood levees. We also see again where the glacial moraines are being covered up by the side slope talus. Here that glacial moraine we see is covered by the coarser talus, so we have the finer textured glacial material overtopped by some of the material coming from the cliffs up above, probably sliding over snowbanks. Again, at Bridger Bowl, we see that pattern of more gentle terrain as we go from the high-standing Bridger Range to the east down into Bridger Canyon. So we were standing right here on top of the Madison limestone, looking to the west, and the geologic map has this mapped as a quaternary, a recent geological aged landslide. And further north we see some other quaternary features, more quaternary landslides, and even signs of glaciation. So avalanches are surface geologic features as well. And of course they tell us a lot about how we should be aware of the pluses and minuses of living in mountain environments and how we need to be careful about citing human activities for safety and economic reasons. In the season changes in the fall and the spring, we have lots of warm days and cold nights. We get frost action, making soil out of rock materials. We see some of that soil getting into the water and being carried, influencing ecological processes and qualities like fishery habitat. We see the development of the thick black surface soils of the grassland meadows of Bridger Canyon, supporting wildlife, supporting hay growing and forage growth. We see the occurrence of these very clay-rich, shaly soils, places that make us think twice about where to go and what the hazards might be if we were to try to site a road or a septic filter field or a foundation in this kind of soil. We see the thick, dark meadow soils, very productive, again, for vegetation, but as we dig down into some of them, we find these sort of rusty streaks. These are called mottles. These are indications that during part of the year the groundwater remains high and the iron minerals in this soil actually rust or oxidize. So we can dig into this soil during the dry season and say, oh, maybe we should be careful about siting construction activities or especially septic filter fields on this soil because during some of the year it appears to be saturated with water. So we can look and learn from nature and find opportunities and hazards for land use activities. Here is a very clay-rich soil that cracks in the dry fall. Notice that the cracks, water is evaporating and bringing up salt that's crusting on the surface. That tells us something again about the chemistry of this soil and also what the groundwater chemistry might be if we were to site a well on this location. And yes, landslides, slope stability, big concerns in Bridger Canyon. And again, we need to be reminded to look at what the maps say about the capabilities of these different geologic materials, the capabilities of the soils formed on them for suitabilities and hazards for land use. simple lessons if we just look and observe. So in conclusion, looking out on Lower Bridger Canyon, we have an appreciation first of the high-standing Bridger Ridge limestones, how they define the viewscape and the landscape, and then the importance of the younger, softer sediments in providing the productive soils for a lot of the ecological processes of Lower Bridger Canyon, and of course providing good places and less good places for home sites, roads, and human activities. The geologic maps are available through the Montana Bureau of Mines and Geology. Google Earth, of course, provides the landscape views, and earth science faculty from years ago up till today, people like Bill McManus, my father John Montaigne, and Dave Lageson have provided a good deal of the background material for this presentation. Thanks for listening. Take care.